Welcome back, everybody. Today we're going to cover section 2.5, horizontal and vertical shifts. If you have two graphs that look exactly the same except shifted around, that is translated in the XY plane, chances are what has happened is there's been an addition or subtraction to the function. If you add or subtract values from a function, that shifts the graph around the XY plane without changing its shape. So if you have f as a function and c is a positive constant, then f of x plus c will shift the graph up c units because you're adding c to all of the y values. If you subtract c from all the y values, you're going to shift down c units. If you add to the x c units, then the x will be larger than you expect because you added c to it. So it's going to shift left c units, which might be the opposite of what you expect. The idea here is you're c units ahead of where you would be otherwise. If you subtract c units, well, that's going to shift it to the right c units, which again might be the opposite of what you expect. But what you need to think here is now it takes c more to get to where you were before. If you add or subtract to the outside of the function, you're going to shift it up or down. So if y equals f of x plus 3, then the graph of f of x will be shifted up 3 units in this equation. If you do f of x minus 2, then now you're going to shift down 2 units. If you have y equals f of x plus 4, that will shift the graph left 4 units because now it takes 4 less to get to the number that we're looking for. And if you do y equals f of x minus 3, that'll shift to the right 3 spaces. You can combine these to shift both up and right, or down and left, etc. So if you have y equals f of x minus 5 plus 2, this is going to first shift the graph to the right 5 units and then up 2. Let's look at an example here. Here we have the graph g of x, which is x squared plus 3. So the red graph is g of x here. So we want to graph the following two graphs. We want to graph h of x, which is g of x minus 2, and then f of x, which is g of x minus 2. So I'll do h in blue. This will be my blue graph. And I'm going to take the g graph and shift it down 2 units. So this point here, the y-intercept, is 3 in g. It's going to go down 2, 1, 2 to 1 in the blue graph. I look for another point. This one here can go down 1, 2, 3, so right around here. This one will be here. And so we get the graph that looks something like this, which is the graph of g of x shifted down 2. If we have f of x equals g of x minus 2, so here's f, I'll do that one in green. Now, what do I plug in to f in order to get the same thing as plugging in 0 into g? Well, now I have to plug in at least 2 to get a 0 into g. So that means when I plug in 2, the value of the function should be the same as the value 2 units to the left. So that means this graph is going to be shifted to the right by 2. So here this will go over 1, 2. This one will go over 1, 2, and we'll have a graph that looks like this. Shifted to the right 2.